Okay, let's look at number one from the first mock exam from last Tuesday. Okay, they give you a differential equation. They do tell you it is logistic, and the first thing I do when I say a logistic equation is I put it in this form if it's not already, and then I will immediately make note that carrying capacity is 100. And let's see, they give you an initial condition. Down here, they ask you to find W prime of 65 and W double prime of 65. And this dy dt is the rate of change for W. So to get W prime of 65, I'm going to use this equation. What you have to be careful of, though, is that W is a function of t. So W of 65, or W prime of 65, is when t equals 65, which means I cannot plug 65 in for the y's. I have to come up here and realize that at 65, W is actually equal to 60. So for W prime, I'm going to start by plugging in 60 for all of the W's there, and that will end up reducing to 8/5. There's no need to completely simplify that. You could stop right here. I did choose to clean it up, especially since you have a calculator. So that was worth 1 point. Okay, so for the second derivative, it gets a little bit hairier because we do have to differentiate this. And what you have to remember is that this derivative is a function of y. It's your dependent variable, which means your second derivative is going to be implicit. So what I did to make my second derivative easier is I distributed only my y. So I'd have 1/15 y minus y squared over 100. Then I left the 1/15 out. The derivative of y would be dy dt. Derivative of y squared over 100 is 2y over 100, which I reduced to y over 50, times another dy dt. And they didn't ask you to write an expression for the second derivative, only to evaluate it. And since I have already established what W prime of 65 is, I can plug that 8/5 right here in for the dy dt's, because I know that that's equal to 8/5. And then I have to plug in 60 for my y, which reduces to 6/5. And that ultimately cleans up to -8 over 375. And so as far as points on this, you got 2 points for finding the second derivative. So this right here was 2 points for getting your second derivative. If you forgot the chain rule, or if you didn't do the product rule, if you chose to do the product rule, then you didn't get anything. And then you got 1 point for this value right here. And then there is an explanation, W double prime. And the way I think of that is I found out that the derivative of W prime is something negative. Okay, and if something's derivative is negative, that means that that function is decreasing. And so that's kind of my thought process. I know that W prime is decreasing since W is described as the amount of workers in the building. W prime would be the rate of the amount of workers in the building. And so this right here is me putting W prime in okay, sorry. That's me describing W prime in words, and I accidentally wrote is changing, is decreasing. So that was a little bit too much. I meant to leave out the is changing and just leave it at is decreasing at that many, and it would be workers per minute squared. Notice that in my explanation, you restate the value, the time value that we used, as well as the answer. Also notice that I left out the negative with my 8 over 375 because the negative is included or implied by the word decreasing. And that was the last point. And so this was a pretty valuable question. That was a 5-point question for number one. Part B, or number A, I guess. Part B is an improper integral, and the very first thing you always do when you see an improper integral is you convert it to limits, and I think that is the first point. And so you always solve improper integrals as a limit. Then we work out the antiderivative, and notice that I kept writing the limit as a goes to infinity. And you remember that the limit is to address the improper behavior. So we address the infinite behavior with an a. I keep writing the limit until I actually evaluate it. Do not just leave that limit off. For the antiderivative, this would be a u sub. Your u is 3t plus 25. The du would be not 1/3, would be 3 dt. So I didn't write it, but I would squeeze a 3 in here with my dt. I would put a 1/3 on the outside, which is where that 1/3 comes from. And then this would be w prime of u. And the antiderivative of w prime of u would be w of u. And I just replaced the u again. So I did the u sub in my head. There's your antiderivative. Plug in a, plug in 0. And right here, if a is approaching infinity, this is essentially w of infinity. What is the population or the amount at time infinity? And that's where recognizing the carrying capacity comes into play, because as time goes to infinity, any logistic model will approach its carrying capacity. And so that's where the 100 came from. W of 25 came off the table, and you end up with 30 for your answer. Part C, a left Riemann sum. The 3 intervals indicated by the table. So if you are doing a Riemann sum, you absolutely must include each rectangle individually. So it's 25 times 2 plus 5 times 10 plus 15 times 3. And that's coming off the table, which you can look at the work and look at the problem and see the table. The Riemann sum only addresses the definite integral. It does not address the 1/45. So the 1/45 stays there. So do make sure that when you're doing Riemann sums, and this applies to trapezoids as well, do not skip steps. Don't write 50 instead of 5 times 10. They want to see the 5 times 10. You will lose points if you don't write 5 times 10. Same thing with 25 times 2. You know that's 50, but you need to write 25 times 2 to get your points. That you could actually stop with that big thing. That's okay. I chose to clean it up to 295/45. And then I did throw that in the calculator just to see what the actual numeric value is. And I'll explain why in just a second. And that comes with the explaining the meaning. Always, when you're explaining the meaning, you want to restate all values and your answer. And so we were looking at the integral from t equals 0 to t equals 45. So you need to specify that in your explanation. And the 1/45 should have reminded you of the average value theorem. So that definite integral is finding the average value of w, and w is described as the number of people in the office. So the average number of people in the office from 0 to 45 is approximately that many people. And here is why I wanted to know that this was about 6.5, because I can go back and look at the table, and from 0 to 45, an average of 6.5. Honestly, it looks a little bit on the low end, but also keep in mind that over half of the interval occurs right here at this very beginning. So there's a lot of time happening between 2 and the values of 2 and 10. And so that's why the average ended up being a little bit lower when I did my Riemann sum. So a 6.5 does kind of make sense. And that's the only reason I wanted to know that value, is to see if I got something that is fairly representative of the average of those W values. And so I like that answer, and I'm ready to move on. Okay, so Euler's method, I'm a big fan of the table. You know you're going from 45 to 85. That means your delta t, you're going up by 20s. And the challenge is to find your delta y's. If you can find out how much y increases each step, then you just simply add it until you get to this spot right here. And to get your delta y, you just move the dx, or I'm sorry, the dt to the other side of the differential equation. So you're just copying the differential equation times your delta t. And then we start plugging in. So I start with a y value of 30. So I plugged in 30, and you end up getting a delta y of 28. And I like to include this table. Your new y is going to be 30 plus 28, which is 58. Here's one thing I didn't like about this problem, and I went back and it messed with my mind some. There actually is an entry in the table that gives you a y value when t is 65. And at 65, they tell you that the y value is 60. However, you are not supposed to use that, because that would be abandoning the Euler's approach. So you've got to use what Euler tells you y is, and y is going to be a 58 according to the Euler's method. Then we repeat. Something else I didn't like about this problem is this year's AP exam, the calculator is supposed to be of minimal help. And I think the calculator was of significant help on this problem because the arithmetic was so brutal. So I don't think if you do see an Euler's method this year, I don't think the arithmetic is going to be this bad. I think they're going to keep it a little bit more straightforward. You end up getting a delta y of 32.48. And when you add that, you get an approximation of 90.48. I didn't write it here. However, I did summarize my findings here my amount at time 85 is going to be approximately 90.48. And I guess I could include workers, the units there. So there is your Euler's method. Is there a time C such that W prime is equal to 1? Anytime you're going to guarantee a derivative value, I start with the mean value theorem. There are some exceptions to that, but that's always my first thought. Then if it fails, I go back and look at something else. In this case, MVT does work. Just remember that if you are ever going to use a theorem, you need to first establish the conditions that allow you to use that theorem. So for the mean value theorem, those conditions are that your function is differentiable and continuous, and that continuous part must be written. If you don't write the function is continuous, you don't get credit. Then the points, this was probably a 2-point question, and I haven't been writing down the point values on these, whatever. It's usually a point for the difference quotient and then a point for the explanation, and that is exactly what this one is. So you absolutely must write down the difference quotient, either in this format or in this format. And if you went straight to writing 20 over 20, you don't get credit. You've got to actually show a difference quotient, which means a quotient, a fraction, with a difference on top and a difference on bottom. You must write that down. So that is 1 point for that part, and then 1 point for kind of for the rest of it. So citing the mean value theorem, actually you don't have to write actually mean value theorem, but using the mean value theorem correctly, that's your 2nd point to get 2 out of 2 on this one. Part D, going back, just talk about the points real quick. Part D was 2 points, 1 for trying or correctly applying Euler's method, and 1 for coming up with the correct approximation in the end. For part C, that was 3 points. You got 1 point for the left Riemann sum, which is showing the base times height. So all that was 1 point. You got 1 point for the actual approximation value. So that was 1 point. And then 1 point for the meaning and context. So there's another point. So that's 3 out of 3. And as far as the approximation value, they would still give you that point right here. You don't have to actually clean it up to 295 over 45 or something similar. And then part B, you got 1 point for starting with the improper integral. I started the point breakdown here. 1 point for recognizing the horizontal asymptote, which is right here. Recognizing the carrying capacity is going to give you 100. And so that was 1 point, and then 1 point for the final answer to make that 3 out of 3. Was that it for number 1? Okay. Then at the end of number 1, part F, is we're finding a Taylor polynomial. And to do that, we're going to use our generic formula, the nth derivative at your center, which in this case is 65 over n factorial times x minus 65 to the n power. And so I started out by finding if I want the 2nd degree Taylor polynomial, I need to work down to the 2nd derivative. And fortunately, we had those values from part A. So this is a case where even if you missed part A, you could import those answers correctly. Even if they're wrong, you can input those incorrect answers correctly to part F and still get full credit. You absolutely must have your Taylor polynomial with all numbers. A lot of people left their answers in terms of like instead of writing 8 over 5, you wrote f prime is 65. You've got to, or w prime is 65. You've got to actually write the value. You can't have like w prime and w notations in your Taylor polynomial. Then after you write that, you go back through and plug it in. You are allowed to stop right here, which I would have on the AP exam. I chose to clean it up to this because I figured some of y'all would, and I would have to grade your work. And then I went one step further to get the decimal approximation. And I probably would have done this much on scratch paper to see what the approximation is, because we were estimating, we used the Taylor polynomial to estimate the amount at 85, which is exactly what the Euler's method in part D was. We were trying to approximate the amount at time 85, and I wanted to see if my two approximations were in the same ballpark. We had 90.48 for D. We had 87.733 for F. Those are close enough to make me feel good. If they were really different, it doesn't mean you're wrong, but it would prompt me to go back and look and see if I'd made a mistake. Because generally, when you do approximation methods like that, they write the problems so that you get something kind of close to the same. All right, so now number 2. We are starting off by finding a limit, and if I ever see a limit on the AP exam where the limit involves a fraction, I'm going to assume it's going to be an indeterminate form. So I start, if you're going to use L'Hopital's rule, you have to show that the top and the bottom approach 0 or infinity, you have to do it completely separately. So I started off by doing the limit of the numerator, which did indeed give me 0. Then I did the limit of the denominator, which did indeed give me 0. Do notice that for g of 4, to evaluate that, I had to go back here and plug 4 in, and you had to get that by looking at areas of the graph that's given. I didn't show it here for the sake of space. But you do get 0 over 0. Then L'Hopital's rule applies. So now I can say that the limit of the original problem is the limit of the derivatives of top and bottom. So the derivative of g of 2x is g prime of 2x times 2. Derivative of 4x is 4. The derivative of e to the x squared minus 4 is 2. You can see the derivatives. And then notice I did write the limit here, but I did not here, because from this step to this step, I'm actually evaluating the limit. I replaced the x's with a -2, and then we had to work that out, g prime. I made a note up here, but anytime I see an integral defined function, I will start by finding its derivative, and this one's pretty easy. Just remember that when you do the fundamental theorem, when you're doing the derivative of these, when you plug the x in for the t, you always want to consider the derivative of what replaced the t. In this case, it's just a 1. But anyway, so the answer to A, you end up getting 4/3 using L'Hopital's rule. This was a 3-point problem. 1 point for showing this part. That was 1 point for showing that the top approached 0. 1 point for correctly applying L'Hopital's rules. That'd be down here, and then 1 point for the answer. So that's 3 out of 3. Okay, so part B, find the absolute maximum. The second you see that, you should immediately think endpoints and critical numbers. Even without the word absolute, anytime you see a reference to max or min, you immediately think critical numbers. And if you are going to find critical numbers, you have to set the derivative equal to 0. You absolutely must write down g prime equals 0. If that is not in writing, you lose points. You have to show every step. Some of y'all are still skipping steps, and it's irritating, but you've got to write down every step. So I wrote g prime equals 0. We made the connection that g is f, and then I found my candidates. You can see that I knocked a few of them out. First, I threw 5 out because it's not unspecified interval. I threw -4 out because if you look at the graph, -4 is a local minimum because the graph given changes from negative to positive. So I threw that one out. That means the only critical number that comes into play is 0. The critical number of 2 was already a candidate because it's an endpoint. And then to find the absolute maximum, I need to find the value of g at each of those places, which goes back to plugging into the integral where they defined where they defined g of x at the beginning. And by measuring areas, you compare those values, and the maximum value, when it says find the absolute maximum, they want the actual y coordinate. So the max value is 2. If they want the x coordinate, the question will say explicitly, at what x does the maximum occur? This one was probably 3 points. I can't remember. Yeah, so you got 1 point just for writing g prime equals 0. You got 1 point for identifying the candidates of -4 and 0, which I did. I've scratched out -4, but I did identify and address it. And then 1 point for the answer. And for extreme value theorem questions, it does say justify your answer, but all of this work is the justification, showing the consideration and that where you evaluated the function. Okay, C was a really, really, really tricky one. I think I've started working this one, and then I had to start over because it was getting ugly and I had to reorganize my work. This is an integration by parts. It's not U substitution. A few people just did them individually, but if you are multiplying two things, you cannot just do the antiderivative of each piece. And so what I saw a few people do is they said, oh, well, that's going to be x squared over 2, and the antiderivative of f prime of 2x is 1/2 f of 2x, which both of those by themselves is correct, but you cannot integrate a product in that way. It has to be addressed either as a U sub or a parts, and this is a parts problem. So when I broke up my parts, I ended up with x times 1/2 f of 2x. I evaluated that from -3 to 1, and then I had to do minus the antiderivative of this, and this became a U sub right here. And when you subbed u equals 2x, you ended up with 1/2 -62 of f of u. And with that substitution, I brought it back to just a generic f. It's not f of 2x, it's f of u. Now I can go back and I can measure areas using what they gave you regarding the graph. Do a bunch of arithmetic, you get -33/4. Now do remember that on the AP exam, I want you to stop right here. I want you to stop right there. I only simplified it here because I figured some of y'all would, and I wanted to be able to compare my answer, whatever y'all's answer was, to any of these variations. But please stop as soon as you have all numbers. That problem was worth 3 points. You got 2 points for the integration by parts and 1 point for the final answer. So that was a 3-point question. And then D was really, really, really quick. The region R is the base of a solid. Perpendicular to the x-axis tells you it's a dx problem. They tell you it's a square. And the area of a square is side length squared. So ultimately, we're going to do the antiderivative of side length squared with respect to x. And then you just have to get your side length in terms of x. And the side length is determined by the function. So I just plugged in f of x. The region began at 2 and ended at 5. And so this was just a 1-point problem, very quick, not much to it, but that's what you should have had for D. And then finally, part E. They tell you that the function's not explicitly given, but they do give you an equation for the derivative. Then they say there's a series that is that derivative. So first thing I did is I just wrote the series from n equals 5 to infinity, -4, 1/2. I just replaced the x with an n, and I noticed that the only place excuse me, the only location of the variable n was in the exponent. That means this is geometric, and the ratio of this geometric series is 1/2. That means this thing converges, and the fact that it converges as a geometric series means you can easily find the sum, and that's what we have to do. So I have to find my first term. So if you plug in n equals 5, your first term ends up being -4 times 1/2 to the 0, which is -4. So that went on top over 1 minus 1/2. You could have stopped right here, which I would encourage you to, but it does clean up to just -8. And that is the end of this problem, I think. Yes, it is.